If I asked you right now, what is the closest star to Earth? You'd probably say the Sun, and you'd be right. But if I asked you what's the closest star after the Sun, the nearest stellar neighbor we have, and told you that orbiting that star, there is a planet that might have liquid water, a rocky surface, and conditions that could, in theory, support life, would you want to go? Because here's the thing nobody talks about when they describe that planet. That planet is also being bombarded, continuously, by radiation so intense that in March 2016, a single flare from its star produced UV light that hit the surface at 100 times the intensity required to kill the most radiation-resistant organisms we know of on Earth. And in July 2025, a new instrument called NIRPS, the most precise infrared spectrograph ever pointed at a nearby star, confirmed what we already suspected. The planet is real, it is Earth-sized, it is in the habitable zone. And surviving there would be one of the hardest things any living thing has ever attempted. This is Proxima Centauri b. And the question isn't just whether life could be there. The question is, could we survive it? Let's start with where it actually is. Because the distance to Proxima Centauri sounds manageable until you do the maths. 4.24 light-years. That's it, our nearest stellar neighbor. But a light-year is not a year, it's a distance. It's how far light travels in 1 year, moving at 300,000 kilometers every single second. Multiply that by 4.24 and you get roughly 40 trillion kilometers. Here is what that means in practice. If you took Voyager 1, the fastest human-made object currently in interstellar space, moving at 17 kilometers per second, and pointed it directly at Proxima Centauri, it would arrive in approximately 73,000 years. 73,000 years ago, modern humans were living in caves. We hadn't invented writing, agriculture was 65,000 years away. And Proxima Centauri is our closest neighbor. This is the first thing you need to hold in your mind. Because everything else we talk about today, the flares, the radiation, the tidal locking, the survival scenarios, all of it happens at a distance so vast that even light takes 4 years to bridge it. The planet that might be able to support life is right next door. And right next door, in cosmic terms, is effectively forever. Now here's what's changed recently, and it matters. In July and August of 2025, the first major scientific results from an instrument called NIRPS, the Near-Infrared Planet Searcher, installed at the European Southern Observatory's La Silla telescope in Chile, were published in the journal Astronomy. The NIRPS team, led by researcher Alejandro Suárez Mascareño from the Instituto de Astrofísica de Canarias, spent 159 nights collecting 420 high-resolution spectra of Proxima Centauri. Their results were the most precise measurements ever taken of this star system. What did they confirm? First, Proxima b is real. Its minimum mass is 1.055 times Earth's mass. It orbits in the habitable zone. Every 11.2 days it completes one trip around its star. Second, Proxima d, a third planet, about a quarter of Earth's mass, is confirmed. Not just a signal. Confirmed. It completes one orbit every 5 days, orbiting far too close to its star to be habitable. But its existence tells us something important. This system is active. There are worlds here. Third, and this is the part that got buried in the excitement, NIRPS found inconclusive evidence for Proxima c, the second candidate planet on a 1,900-day orbit. It might exist. It might not. The data is genuinely ambiguous. What NIRPS couldn't tell us, what no instrument we currently have can tell us, is whether Proxima b has an atmosphere, whether it has liquid water, whether anything is alive on its surface. All we know is that the numbers say it could, and the physics of its star says it probably shouldn't. To understand whether humans could survive on Proxima b, you first have to understand what Proxima Centauri actually is. It's a red dwarf, about 12% the size of our Sun, about half the surface temperature, so dim that you cannot see it with the naked eye from Earth, despite being our closest stellar neighbor. Red dwarfs sound harmless. They are not. Proxima Centauri has a magnetic field approximately 600 times stronger than our Sun's. And that magnetic activity translates into something that makes the planet next to it a genuinely dangerous place to live: stellar flares. In March 2016, the same year Proxima b was officially discovered, Everyscope, an array of small telescopes at the Cerro Tololo Observatory in Chile, captured the first naked-eye superflare ever detected from Proxima Centauri. In a matter of seconds, the star's optical brightness increased by a factor of 68. The bolometric energy released was 10 to the power of 33.5 ergs, roughly 10 times larger than any flare previously detected from Proxima. That single flare produced UV light that reached the surface of Proxima b at approximately 100 times the intensity required to kill simple UV-resistant microorganisms. Not complex life, not humans, simple, radiation-hardened microorganisms. Kill at 100 times the lethal dose. And in March 2025, a new study using the ALMA radio telescope, published in the Astrophysical Journal, added the first millimeter-wavelength flare measurements from Proxima Centauri. The results showed that flares at this frequency occur more frequently and with more energy than previously modeled. The authors were direct. The flare environment around Proxima Centauri is more extreme than prior estimates suggested. For context, on Earth, our Sun occasionally produces solar flares that can disrupt satellite communications and knock out power grids. The 1859 Carrington event, the most powerful solar flare in recorded history, took out telegraph systems worldwide. Proxima b lives through something equivalent to a Carrington event not once a century, but potentially multiple times per year. Here is the central question for habitability: does Proxima b even have an atmosphere? And the honest answer from the science is probably not a thick one. Not anymore. A study from NASA's Goddard Space Flight Center, led by Catherine Garcia Sage, modeled what happens when an Earth-like atmosphere is placed in the radiation environment of Proxima b. Using NASA's Chandra X-ray Observatory measurements of Proxima Centauri's average radiation output, the results were stark. Proxima b receives extreme ultraviolet radiation hundreds of times greater than Earth receives from the Sun. That radiation generates enough energy to strip away not just hydrogen, the lightest molecule, but oxygen and nitrogen over time. The model showed that an Earth-like atmosphere at Proxima b's location would be depleted up to 10,000 times faster than Earth's atmosphere loses material to space. 10,000 times faster. At that rate, a thick Earth-like atmosphere could be stripped away in a geologically short period of time, millions of years. Not billions. This was a simple calculation based on average activity from the host star, Garcia Sage noted. The actual rate, accounting for the frequent superflares, could be even worse. And separately, a modeling study from Princeton showed that without a strong planetary magnetic field, ion escape rates from Proxima b could be roughly 100 times higher than those of Earth, Mars, and Venus combined. Even with a magnetic field, the escape rates remain higher than anything in our solar system. So the picture looks like this: a planet that may once have had an atmosphere, possibly even oceans, that over billions of years has had that atmosphere progressively stripped away by the star it orbits. Not destroyed in one catastrophe, just slowly, relentlessly thinned. Like watching a fire extinguish itself. Gradually, inevitably. So, can humans survive there? Let's actually think through the scenarios honestly. Scenario 1. The surface is dead. If Proxima b has no meaningful atmosphere, its surface is exposed directly to the stellar wind, cosmic rays, and UV radiation from frequent superflares. No ozone layer, no magnetic shield. The surface of a planet without atmosphere in the habitable zone of a flaring red dwarf would look something like the surface of Mars, but with a star 20 times closer that is actively trying to strip away whatever is left. In this scenario, humans could not survive on the surface. Not without an extraordinary amount of engineering protection. Every minute outside a sealed habitat would be a radiation exposure event. Scenario 2. The Terminator Zone. Proxima b is almost certainly tidally locked. One side of the planet permanently faces its star. The other is in permanent night, with temperatures potentially dropping to -100 degrees Celsius or lower. The star-facing side is perpetually blasted by radiation and heat. But the edge, the Terminator Zone, the narrow ring between permanent day and permanent night, is different. Depending on the atmosphere, if one exists, temperatures there could be moderate. Wind patterns driven by the extreme temperature differential between day and night could circulate what warmth and atmosphere remains. A thin strip of potentially survivable conditions, caught in an eternal twilight. It would look like permanent sunset, or permanent sunrise. Every day, forever. Humans building in that terminator zone, underground habitats, radiation shielding, enclosed ecosystems, could theoretically survive there. Not comfortably, not easily, but physically possible. Scenario 3, underground. This is the one astrobiologists find most plausible, not just for humans, but for any native life that might exist. If liquid water exists on Proxima b, and the habitability zone position suggests it could, given the right atmospheric history, it would most likely survive underground. Shielded from surface radiation by rock, kept liquid by geothermal heat generated by tidal interaction with its star. For humans, underground habitats would solve the radiation problem. Rock is excellent shielding. A few meters of Proxima b's crust between you and the star's radiation would reduce surface doses to manageable levels. If you could access geothermal energy and subsurface water, you would have power and a water supply. You would also never see the sky. Here's where we have to be honest about what survival actually requires. Getting to Proxima b in a human lifetime requires technology we do not have. Breakthrough Starshot, the $100 million laser sail initiative announced by Stephen Hawking and Yuri Milner in 2016, proposed sending gram-scale probes at 20% of the speed of light. Even if that worked, the probes would arrive in about 20 years, fly through the system in minutes, and send back data at the speed of light over 4 years. No landing, no humans, no return. As of September 2025, Scientific American reported Breakthrough Starshot has spent approximately $4.5 million of its $100 million pledge and is on indefinite hold. Not cancelled formally, just quietly, significantly stalled. A crewed mission, carrying the people, equipment, food, water, air, medicine, spare parts, radiation shielding, and fuel for deceleration that a human journey requires, is so far beyond current technology that no credible timeline exists. Fusion drives, antimatter propulsion, generation ships, all theoretically possible, none anywhere near ready. The minimum viable crewed mission to Proxima b might be achievable in 200 to 300 years, with breakthroughs in propulsion that we cannot currently engineer. It might take longer. And when humans arrive, after a multi-decade journey, they would step out onto a planet that has been bombarded continuously for billions of years. With no guarantee of an atmosphere, no guarantee of water on the surface, no guarantee that the terminator zone is as hospitable as models suggest. They would be betting everything on calculations made from 4.24 light-years away. Here are the things you are not told about Proxima b. The challenges are extraordinary. But the timeline of this star is also extraordinary. Proxima Centauri is estimated to have a lifespan of approximately 4 trillion years. The current age of the universe is 13.8 billion years. Our Sun will die in roughly 5 billion years. Long after Earth is gone, long after our entire solar system has grown cold, Proxima Centauri will still be burning. If life were to emerge on Proxima b, even simple microbial life, it would have 4 trillion years to evolve, to adapt, to survive the flares, to develop whatever biochemical defenses a world like that demands. Life on Earth has existed for roughly 3.8 billion years. In that time, it went from single cells to complex organisms capable of building telescopes and asking questions about distant planets. 4 trillion years is 1,000 times longer. We cannot imagine what evolution does with 4 trillion years. But if Proxima b has even a fraction of the conditions needed to start, water, chemistry, energy, the patience of that red dwarf is the most remarkable thing in its solar system. And for humans, the question of whether we could survive there is really a question of how much we are willing to become different from what we are now. Underground civilizations, radiation-adapted biology, closed ecosystems, children born under rock, who will never see an open sky, who will call a terminator zone twilight the most natural light there is. It wouldn't be survival, it would be transformation. The NIRPS instrument pointed at Proxima Centauri for 159 nights. 420 spectra, the most precise measurements ever taken of the nearest star system to our own. And what it confirmed in July 2025 is that the planet is there. Real, measured, Earth mass, in the habitable zone. Everything after that is a question. Does it have an atmosphere? Unknown. Does it have water? Unknown. Could life survive there? Possibly. Underground, in narrow conditions. Could humans survive there? With extraordinary technology, extraordinary determination, and extraordinary willingness to change, maybe. The question, can humans survive Proxima, is really asking something deeper. It's asking, how far are we willing to go? How much are we willing to become? Because Proxima b is not waiting for us. That star has been firing radiation at that planet for billions of years. Whatever is there, or whatever isn't, has already been decided by physics. The only thing left to decide is whether we go and look. 4.24 light-years away. The nearest planet that might support life. Impossibly close.